Hello everyone! In this problem, we're looking at Mr. Macheski throws his favorite rubber duck into the air to see if it has learned to fly yet. It has not. He throws it up with a velocity of 20 meters per second off the top of the school, which is 10 meters, off the ground. I want to know, A, what is the maximum height of the duck, and that will be off of the ground. B, how much time passes before the duck hits the ground? And C, what is the velocity of the duck when it strikes the ground? So, this problem is going to be much easier if we start by drawing ourselves a little sketch. So, let's go ahead and say, this is the school. It's 10 meters off the ground. Mr. Macheski throws the duck up, and then it comes down and hits the ground. In this problem, we need to set our reference point. Now, in the past, our reference point has been very clear. It's been very obvious what that should be. But in this problem, that's less so. Is my reference point the top of the school? Is my reference point the ground? Is my reference point the highest point that the duck reaches? That's going to be something that you'll have to think about. In this case, our zero throughout every part of this problem we do has to stay the same, because all of our answers are going to be in reference to that. So I'm going to set my reference point as the ground. I encourage you to do the same thing. We need something that is firm, unmoving, it's not changing. So any calculation we do from here needs to have an xi of 10, okay? So our next step is we're going to set up our equations. Remember, we have 2s equals xi plus vit plus 1 half at squared. And a equals vf minus vi over t. Now, we're getting a little bit of a taste of what a two-part problem really looks like. So we're going to split this one into two separate parts. We've got our A part, which is what is the highest point the duck reaches. That's all going to be in this first bit of motion, from here to here. And then, how much time passes before the duck hits the ground, and what's the velocity of the duck when it strikes the ground? That velocity when it strikes the ground is going to be from here to here. It's going to be the second bit of motion. And we're going to have to find our time 1 and our time 2 and add them together for our time total. And that's going to be the time from when Mr. Macheski throws the duck to the time it strikes the ground. So let's go ahead and set up two variable lists. That's going to make everything so much easier. So when you see these kinds of problems, this is the first step. This is why we practice setting up problems. We see one part, two parts, okay, two variable lists. So S equals xi equals vi equals vf, a, and t. That's going to be part A. And then we'll have part B. It's going to have S, xi, vi, vf, a, and t. Now, what if you're not sure if a problem has multiple parts? Well, the first thing you can do is you can always just focus on this first part. You focus on the first question that's being asked of you. Sometimes I'll ask you for the acceleration, but to find the acceleration, you need to find the time. You would reach that conclusion by listing out your variables and looking at your equations. And it really comes with practice. So as you guys are watching these videos, make sure that you're writing this out along with me. That'll be the practice that you need to get really good at this stuff. So for our first part, do we have an S? It is unknown. Do we have an xi? Yes, we do, because we already established by drawing this out that our 0 is the ground, so our xi for this first part from here to here has to be 10 meters. And S is going to be some amount above 10 meters. Okay, great. So xi for part 1 is 10 meters. All right, vi. Well, he throws the duck up with 20 meters per second. Okay, so at this point, my vi here in part 1, part A, my vi is equal to 20 meters per second. Now notice, is that going to be positive or negative 20 meters per second? Well, that depends on my frame of reference. I'm setting my frame of reference to be up is positive and down is negative. So, excuse me. So, my VI in part A is 20 meters per second. Now, what is my acceleration? This is a free fall problem. I always have the same acceleration in a free fall problem. Well, always the same when it's on Earth. If we're on another planet, then we would use a different acceleration because it's dependent on that body. So, almost all of the time we're going to be working with the acceleration on Earth. We're not going to get too complex with that. So it's always going to be that negative 9.8. In our case, it's negative because towards the ground is negative. If you had towards the ground being positive, you'd have a positive 9.8. So you always got to watch that sign on that acceleration due to gravity. It always depends on which problem you're solving. Okay, so our acceleration, negative 9.8 meters per second squared. All right, and time. Well, do I know time? I do not. What else do I need? I need velocity final. Okay. What's my velocity final going to be? If I want to know the height that the duck reaches, the highest point, well, that's going to be the point where my acceleration has caused my velocity to slow down to 0. The highest point is going to be when my velocity hits 0 and starts going back the other direction. So I throw the duck up, acceleration is slowing it down until it arcs, hits a 0 velocity, so my final velocity is going to be 0. That's something that you can always see, because you see this arc. When it hits that tippy top point, that is going to be a 0 velocity. Now, the key we need to remember is that for part B, our part B starts from here to here, and our part A starts from here to here. Our part B starts where part A ends. So everything final in part A is going to become our initial in part B, okay? That includes this S. So our final velocity in A is going to become our initial velocity in B, and our S in A is going to become our XI in B, okay? So I'll come back to that in a minute. But first, let's solve part A for S. Now, part A, S equals xi plus vit plus 1 half at squared. All right, I have an xi, I have a vi, I have an a, but I'm missing a t and an s. So I can't solve that yet. I can't eliminate any of these variables. I cannot solve it. So the first thing I need to do is I need to find time. I have another equation. My other equation being A equals VF minus VI over T. Well, let's see. I have acceleration, I have velocity final, and I have velocity initial. So I could solve all that for time. Very nice. That's the benefit of having written these out over here. I know I've got two equations to work with, so I can always look back and go, well, I can't solve for this right away. Is there anything else I can solve for? Is there anything else I can figure out right now? What I can figure out right now is time. So let's rearrange that real quick. I know that multiplying both sides by t is going to get rid of t on here and bring it over here. And then dividing both sides by a is going to get rid of the a over here and bring it over here. So I'm going to have a result of t equals vf minus vi over a. And I'm kind of rushing through this part because I feel like we've had enough practice. If you haven't, let me know. we can come in for ELT and we can actually get more practice on this. So, VF, 0, minus VI, 20, over negative 9.8. Does that make sense? Well, that should make sense because 0 minus 20 is going to be negative 20 divided by negative 9.8. That means my time is going to be positive, which it should be. So that's another way we can check that all our signs are correct. So, negative 20 divided by negative 9.8. It's going to be 2.04. So, 2.04 seconds. Okay. And now I have all the information I need to solve for S. Great. Let's plug it in. Okay, so xi. So I'm going to bring this down here. The line there so I know that I'm switching spots. So S is going to be equal to xi, which is my 10, plus VIT, which is going to be 20, times 2.04, plus a 1/2 a negative 9.8 times 2.04 squared. Okay, that's going to result in 30.4 meters for our S. Now notice, it was really simple to just plug all this into the calculator because I was able to insert all of it because I have it nice and organized over here. That'll save you a lot of trouble. I'm really going to hammer that point. Okay, so now I have S, 30.4 meters. So that's my part A. Put a box around it. Beautiful. Okay, so now how much time passes before the duck hits the ground? Oh, good. I would have needed to find my time for part A anyway. Great. So now I'm going to need to find my time for part B. So I'm going to make a little bit of room for myself here. All right, now that I've made a little bit of room, let's list out our variables for part B. Remember, everything where part A ends is where part B begins, so my S is going to become my XI. So 30.4. My VF is going to become my VI. 0 meters per second. My acceleration, always going to be the same because it's a free fall. It's going to be constant. Negative 9.8 meters per second squared. My frame of reference stays the same throughout the whole problem. I'm looking for T, and in part C, I'm looking for VF. Do I know S? I actually do know S. That's very useful. S is going to be where it hits the ground. S is where it ends up. Because I've set my ground to 0, I know S. That's fantastic. So, S is 0. So that should result in some interesting numbers. Okay, so we're going to have to do a little bit of rearranging here. So let's go ahead and find our time using our S equation. I know I need to use my S equation because I'm missing velocity final and T, so I wouldn't be able to solve for either of those in this position. Okay, so my S equation, S is going to be 0 equals XI 30.4 plus VIT. VI is 0, so that's going to cross out. So plus 1/2 AT squared, that's going to go 1/2 AT squared, which is going to be negative 9.8 T squared. Okay. So let's get this 30.4 away from this side. So we're going to subtract both sides by 30.4. So we're going to end up with a negative 30.4 equal to a 1/2. You know, we'll simplify that right away. 9.8 T squared. So negative 30.4 equal to 1/2 times 9.8. Negative 4.9. You will get used to that number. That's going to come up frequently. I can already see that this is going in the right direction because I'm going to have a negative 30.4 divided by a negative 4.9. It's going to make a positive number, giving me a positive T. That's good. I need a positive T. So, negative 30.4 divided by negative 4.9. That's going to be 6.2. So 6.2 is equal to t squared. Then I need to take a square root of both sides. All right, and that's going to be 2.49. I'm going to go ahead and keep it rounded to that 100th place because that's what I did in the first part of my problem. I want to be consistent, so 2.49 seconds is my T2. Okay, so let's go ahead and write that in. 2.49 seconds. So the part B is asking me for the total time, how much time passes before the duck hits the ground. So from the time that I threw it up, the time it hits the ground, how much time passes. And just so you know, you can always ask for clarification. If we're on a test and you've got a question like this and you are curious, are you asking for the time between the top and the bottom, or the time that you threw it up and it stopped, or the total time? You can always ask. So you're always free to do that. So I'm going to have to add in one more variable to my list. It's going to be total time. So I'm going to do T sub capital T for total is equal to 2.04 plus 2.49. So that's going to be 4.53. So 4.5 seconds about from the time I throw the duck up to the time it lands on the ground. Now, the last thing we need is a velocity final. So let's get that kind of in its own section here, and we'll put our acceleration equation down here, because that's the only thing I've got left to find velocity final. Great. Acceleration equal to Vf minus Vi over t. Rearrange it to find velocity final. It's going to be At equal to Vf minus Vi. Vi is 0. Drop it right out. So At equals Vf. Great. Okay, so which t am I actually going to use here? Because I've got 3. I have 3 of them. I have a T1, I have a T2, and I have a T total. Well, the time that it's accelerating for is from the time that Vi is 0 and Vf is going to hit the ground. So I'm asking for this time. Okay, so I'm going to use my T2. So it's going to be negative 9.8, we're running out of chalkboard room here, times T of 2.49 is equal to, and notice this should be a negative number, which would make sense because my Vf is going to be going in the downward direction, which we defined as negative. So my final velocity is going to be a negative 24.4 meters per second. Perfect. I'll just put that back in my variable list. Negative 24.4 meters per second. Box it off. Box that answer off. I've got everything I need. Thanks, guys.